How do you know you didn't put the next electron in 3D? I look at the periodic table. Periodic table tells me that after electron 18, they put the 19th in the 4s1. That's weird. What happened to 3D? Well, I guess you're ignoring it. What did you do with the 20th electron? 4s2. Well, are you ever going to go back and fill in the 3D? Yeah, right now. Right now. Yes? And so here's a little exception to the rule. This is not an exception. 3D1, 3D2, 3D3. I'm going to skip you for right now. 3D5, 3D6, 3D7, 3D8, skip you, 3D10. Now, in the book, they have a special page just for this one exception. And it's the only exception I'm going to ask you. There are many exceptions in the D and the F orbitals. I'm not going to ask you that. I'm not going to ask you except for this one. Where are you? Where are you? What page is it? I had it yesterday. There it is. Okay, one more time. Here we go. Now, if you had one of these from yesterday, here's what they think is happening in the D block. Here's what they think is happening in the D block. You everybody know how to do orbital diagrams? When you're in S orbital, you go up, down, right? When you get in the P, D, or F, you go up, 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 down, 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 up, up, up. All right, everybody okay? Okay, so let's take a look. It goes up, down, up, down, up, down, 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 up, down, up, and down, down, down. And then the next one does not go here. Does not go 3D. It goes where? And again, how do I know that? The only reason I know it, I look in the periodic table. The next electron goes to 4s1 and then 4s2. Okay, now here is what happens next. Then they go down. Scandium's where you start filling this out. So let me redraw that, okay? The first one goes here. Scandium is 3D1. Now he still has 2 here. It's 3D1. The next element, 3D2. 3D3. Now, the next one should be 3D4. And here's the first exception. So chromium, it should be 3D4, but if you look on the periodic table, it'll tell you it's 3D5. You said, what the heck? You can't just come up with an electron. Where'd that come from? How do you get 3D5 when you're the 4th element there? Where'd you steal electron from? Over here. He's the first guy. Chromium's the first one to have, and somebody made their name famous for called the half-filled rule. If a sublevel is half-filled, it's very stable. And so what happened is by putting 5 here, you say, where'd you get the extra electron? Okay, it's 4s1 now. What? Okay, what do you go do with the next element? I'll give it back. So after chromium, manganese goes back, and it's also 3D5, but it puts it back to 4s2. Now let's get back in a pattern. 3D6, 3D7, 3D8. What's the next one? It should be 3D9, shouldn't it? Ba-boom, ba-boom. Then it becomes 3D10. Where'd you get the extra electron from? I stole one of those again. And how does zinc finish it out? I'll give it back. Now you get a new one. Now, again, I'm not gonna. The whole test is not on that. I'll have like one question on the exception. Like I'll say right out the electron configuration for chromium. All right, let's see if we can do it. Let's see if you remember. Ready? 1s2, 2s2, 2p6, 3s2, 3p6, 4s what? I'm doing chromium. 4s what? It's an exception. 4s1, 3d 1, 2, 3, 4, 5. That's the first exception, isn't it? Now, give me back my electron over here. Now it's 4s2, 3d 5, 3d6, 3d7, 3d8, 3d10. Where'd you get that electron? 4s1. And then now you go back and 3d10 with give me back 4s2. I'm not here to teach. That's not my main lesson today. It's the one exception they talk about. It's the only exception I'm going to ask you about. I do want you to know a little bit about the rest of the periodic table, and I'll spend about 2 minutes on it, and then I'll finish the chapter today. All right, so we know if this is 4s1, 4s2, you say 3d1. Let's go here. 5s1, 5s2, subtract the number, 4d1. 6s1, 6s2, lanthanum is, everybody? 5d1, isn't it? 7s1, 7s2, actinium is 6d1. That's pretty easy? But let's take a look at this. Lanthanum is in the D block. It really is 5d1. But what's the element after lanthanum? And what block are you in when you go to cerium? That's the F block, isn't it? Now you got to subtract another number. Watch this now. Ready? 6s1, 6s2, subtract the number, 5d1, subtract another number, 4f1. Let's try it again over here. 7s1, 7s2, subtract the number, 6d1, subtract another number, 5f1. If you know that much, I'm okay with that. You got it? I'm okay if you just know that much. There's something, for whatever reason, when I ask this, many people don't know. What period is cerium in? What period is cerium in? Anybody want to volunteer, try that? Yes, Caroline?
6.
Which one?
6.
6, let's take a look. Cerium is right after lanthanum. Cerium is in period 6. Thorium is right next to actinium. Thorium is period 7. Get that? All right. The other thing is, we did electron dot, didn't we? Did we do electron dot? Electron dot is not that difficult. What do the dots represent? What do the dots represent? All the electrons? Not every year. Every other year, I've had people put like 30 dots around an element. I thought, whoa. Do you think a scientist think that would be smart? Hey, give me an electron dot for that. No, not going to put 30 dots. What's the most number of dots anybody can have? 8. Nobody has more than 8 electrons in their outermost energy level, doesn't it? Nobody. You'll never do more than 8 dots. And the order is the first 2 pair up, the next 3 don't unless they have to, and then they start pairing up. You said, oh wait, the first 2 pair up because those are the S orbitals, aren't they? Up, down, right? The next 3 don't. P, 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 up, 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 and then what? Down, down, down. That's what you said. The first 2 pair up because it's S orbital. The next 3 don't because they're in P orbitals, and then they do pair up. Okay, so let's pick one. Let's do, how about one more electron dot for oxygen? What's the oxygen's electron dot? How many valence electrons they have? And don't make more work than you have to. How many valence electrons oxygen have? 6. It's right there for you. Now, where are the 6 valence electrons? Okay, I'm in period number 3, so it must be 2s2 and 2p4. There they are. So here we go. How do you do electron dot? 1, 2, 3, 4, 5. Oh, now I have to pair up. There you go. Is that pretty easy? Everybody in oxygen's column has the same way. Let's do a hard one. Now do that one. All right. I'm going to wait till you finish, and I'll tell you the answer. What do you think? Got it? All right, look to your neighbor. Show your neighbor what you had. And go, oh, I didn't know he was going to do that. You show your neighbor what you had. What's the electron dot for O minus 2? All right, how many electrons total does O minus 2 have? Total. Uh-oh. Jonathan. 10. What would you do with 10 electrons? I put 2 in the first energy level and what? 8 in my outermost energy level. I have 8 valence electrons. Noble gas configuration. I'm not a noble gas. My nucleus is not a noble gas, but my electrons are in the same arrangement as a noble gas. Now, by the way, if you leave off that -2 and you put 8 dots around there, that's wrong. Oxygen will never have 8 dots around it, but oxygen -2 ion, yes. All right, well, that's about it for that. And I told you that the last thing we're going to do, I'm assuming that you've done enough homework that you know that the names of everybody, right? You know, the S block is the alkali metals, alkaline earth metals. The D block is what? What do you call these? What do we call them first semester? Uh-oh. We got to hurry a little bit. Transition metals. And then you had the P block. Remember the P block? Right there? And then this is the F block. Okay. Let's see. What else? Okay. I guess I'm trying to think what else. What other kind of questions are here? The lanthanides and actinides are the F block, right? Noble gases are part of the P block. The only exception would be helium. I actually have seen some periodic tables that put helium here because he has 2 valence electrons, but he's so special because 2 makes you not want to react. And that's why I want to put it over there with the other noble gases, but most of them will separate. See how they separate helium from the rest of them? It's the only noble gas that doesn't have 8 valence electrons. It only has 2 because it doesn't have that many. All right, so now the last thing we're going to do is I ask you to read the last 3 pages or so, and this is this fancy word called periodicity. And all that means, what are the trends? What are the trends in the periodic table? Now, we already know about electron configuration. You're pretty good at that. So let's take a look. You already know this from first semester. Where are the metals? Where are the nonmetals? Where are the metalloids or semimetals? They're okay on that? We've done that all year. When you're making compounds, metal, nonmetal, remember that? That should not be new to you. This whole page should not have been new. Now, they have a thing here. Let me check to see what it says here. Okay. All right. So the first thing they're going to talk about is how big the atom is, okay? So what do you think the trend is on atomic size? Okay, tell me what you think. If you go down any group or family, if I said, compared to this guy, are you bigger or smaller? Are you bigger or smaller than me? All right, what happens as you go down a column, a group or family? Who knows? Who read it and said, I know. Tyler, what do you think? Oh, you know. Wait, you know? Ethan, you know?
Yeah.
What happens?
They increase
What does?
the size.
That's called the atomic radius, isn't it? The atomic radii. Now, what's the theory? The theory is hydrogen only has 1 energy level. All right? Lithium has 2, so guess what? The second energy level is bigger. The third energy level is bigger. And that makes sense to me. The atom gets bigger in every case as you go down. That makes sense to me. But the one that doesn't make sense, what happens to the size as you go left to right? What happens to the size when you go left to right? What do you remember reading there? There's a big picture in your book. What happened there? I'm getting more protons. I'm getting more electrons. But what's happened to the size of the atom? And the theory is the electrons in the second energy level, they're about the same distance away from the nucleus, but you keep putting more protons in the nucleus. More positive charge pulling on electrons that are about the same distance. It's like having not 2 babysitters watching 8 kids, but 3 babysitters, right? Anyway, and so what happens is they think, as you add more protons and electrons are about the same distance away, they put them in a little tighter. Now, I'm not in this industry, but there are some industries that are based on the size of atoms. I saw one thing that was about unbreakable glass, or nearly unbreakable glass. And they said, we had to find the size of an atom that would fit in between these other atoms and make it sturdier. And it was all about atomic size, and that's how they made like bulletproof glass and stuff like that. Okay, what do you think about atomic size? Is that pretty easy or not? So let me ask you the honors level question. Honors level question. Which one's bigger, lithium or lithium plus one ion? Uh-oh. What about ionic radius? Which one's bigger? Lithium, lithium plus one. Anybody want to take a guess on that? Tyler, I didn't get calling you, so what's your best guess? Well, 50-50 chance. I'd just say one of them is bigger than lithium plus one. Why do you think that? Okay. Thank you for being honest. How many energy levels does lithium have? 2, doesn't it? How about lithium plus one? What does lithium plus one mean? I lost my valence electron, didn't I? I don't even have a second energy level, do I? So a lithium plus one ion would be what? That'd be smaller. Matter of fact, every metal's ion is smaller than the neutral atom, because every metal loses valence electrons. Every one of them loses either 1, 2, or 3, and becomes it loses the whole energy level and it becomes smaller. So if you're a metal, the ion becomes smaller. What about non-metal? Which one's bigger, chlorine or chlorine minus 1? Uh-oh. I don't know about that. Chlorine has 17 protons trying to attract 17 electrons. But if you gave me an extra electron, that's 17 protons trying to attract 18 electrons. What happens there? I had a pretty tight rein on the 17 electrons. You put another one in there, I can't pull them. So for nonmetals, the ions are actually bigger than the neutral atom. I don't have a huge number of questions on these, okay? Most of the questions we've already done, okay? This last part is atomic radius and ionic radius, and we have one more right here. Okay, ready? Last thing. This is the last new thing of the chapter. All right, ionization energy. Are you ready? We're ready? Did you read it? I'm going to read it for you. Ionization energy of an atom is the energy required to remove an electron from an individual atom. Okay, let me ask you this. Who, quote, in the first semester, who tends to lose electrons? Look at the periodic table. Which elements tend to lose electrons? What are they called? Starts with an M. Metals. Find the metals. Got it? Now, if they have a tendency to lose electron, it wouldn't take as much energy to get them to lose an electron. Ionization energy says, how much energy does it take to get you to lose less electron? Metals tend to have small ionization energies. It doesn't take much energy to get rid of an electron. Who would have higher ionization? Who doesn't really want you to take their electrons away? Not metals, but non-metals are trying to gain them. They have high ionization energies because I don't want you to take my electrons away. And you know who has by far, the highest ionization energy? Just try to take my electrons away. You have to pump in so much energy, you have to crank it up to 2,000 or 3,000 degrees. Who by far has the highest ionization energy says, I really don't want you to take my electrons away? Isn't that right? Why are the noble gases so stable? They're so stable, they don't want to gain electrons. They don't want to lose electrons, and they really are not going to let you take their electrons away. Well, that's called ionization energy. All right, and the last thing I'm going to say is this. All the metals, right? Not counting hydrogen. That's not. See all the metals? Of the metals, who would have the lowest ionization energy? Who's really metallic? Who's really metallic? I really want to lose electrons. What do you think? Like, I have to lose 3 electrons. I'll do that. I'll do it. I'm gonna lose 1. Who would have the lowest ionization energy in the metals? As you go left, ionization goes down. It's really easy for them to lose electrons. And aren't they the most reactive metals on the periodic table? Why are they so reactive? Because they really want to lose an electron. They really do. Now watch now. If you go left, they become more metallic. And guess what? As you go down, guess what happens? Watch this right here, ready? I only have 3 electrons. And I have 3 protons pulling 3 electrons, and I have a pretty tight rein on them because they're pretty close. What about the 87th electron? Where's it at? Oop, oop, oop. It's way, way out there in the 7th energy level. What's between that and the nucleus? The protons are here, and I got energy level 1, they're negative. Energy level 2, negative, 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 negative. And finally, in the 7th electron, it says, it's like, where is that nucleus, you know? I got all these negative, it's called the shielding effect. I got all these negative things in front of me. Do you even know I'm here, nucleus? Oh, you don't? Okay, I guess I'll leave. Here, cough on me, and I'll leave. It takes very little energy, almost none, to get him to lose an electron. Last but not least, here we go. If you're a metal, and you want to be, the lowest ionization energy goes left and down. So the metallic characteristic increases as you go left and down. What about nonmetals? You become more like a nonmetal as you go right and up. Who's the most ferocious nonmetal? Fluorine. I want to gain electrons so badly, I will rip it off your face. Fluorine, if you want to get, you know what element they use to try to form a compound with noble gases? Fluorine. I really want an electron. I really want to gain electron. You get that? All right. That's it. That's it. If you were just to read those 2 pages, just let it fall into place, and there's only a certain number of questions on periodicity. All right, I'm done. What I'd like you to do is, if you can sit with somebody, and I gave everybody a practice test. Anybody not here yesterday? Okay, go ahead and take the practice test and sit down with somebody and see how well you do on it, okay? Again, I won't be able to help you after lunch today, but I will be here after school. Okay, I'll be here after school.